All right, hey, this is lesson 10 of Unit 2 Topic 1, and this is day 1. I'm going to split this up into 2 different days, and lesson 10 is basically a review of everything we've done in this entire topic, talking about key features of graphs. And we've really looked at 2 types of functions. We've looked at linears versus exponentials. Linears are a arithmetic sequence, which means it's add. It could be adding a positive or a negative. It could be increasing or decreasing. And then exponentials are when it's multiply, which is called a geometric sequence, which means it's either multiplying by a number, a whole number, or anything greater than 1, which would make it increase, or anything less than 1, like a fraction, would make it actually decrease. But we haven't really done a whole lot of those. So this is starting at -5, and it's increasing by 3. So I'm going to be very strategic in where I put my x and y axis. I'm going to put it all the way down here. Oh, no, I'm not going to put it all the way down there. I'm going to put it all the way up here because I'm going to start at -5. 1, 2, 3, 4, 5. And then it's going to increase by 3. 1, 2, 3. And then the next term is going to be increased by 3. And there you go. There's what the line looks like. So for the next question, this is what we call a recursive formula. Hopefully we've covered that. And this means that it's going to start at 1. That's your starting point. The 0th term is 1. And then every number after that, to find any number, all you have to do is take the previous number and subtract 7 from it. So I'm going to put my axes way up high this time, because the first number is 1. That's easy to graph right there. And then every number after that, all you have to do is take the previous term and subtract 7 from it. So the next term is 1, 2, 3, 4, 5, 6, 7 below it. All right, so there's what that function looks like, straight line. Or you can always put stuff into the calculators. You can't put recursive formulas in the calculator. Only do explicit formulas. Because honestly, between you and me, explicits are way better than than recursives, because recursives are only helpful to finding the next term, not any term. So in this case, we're looking at all the key features. Like I told you, this is a review of the last few units. So the domain of this function is from -3 to 4. 4 is when it stops. X can be anything in between because it's a continuous function, not discrete. The range means the lowest to highest. The lowest point is 0. And f of x can go all the way up to 4. Because there's the highest point, lowest point. Maximum is 4, and minimum is 0, because that's what the range says. The increasing intervals, when does it increase? From -3 to 1. So x can be anything in between -3 and 1 and be increasing on the function. And when is it decreasing? When it's after 1. So from 1 to 4. And that would be right here, this piece, from 1 to 4 is when it's decreasing. The x-intercepts is, there's 1 right here. It crosses the x-axis at 4, and it crosses the y-axis, it looks like right there, at about 3. I'm going to say it's 3, even though it looks like it's like 3.1 if you look really, really super close. This is the easiest question right here that you'll see the entire time, because this, ladies and gentlemen, is not a function. And the reason why it's not a function is because it does not pass the vertical line test. If I draw a vertical line, that domain of 3 has 2 different ranges. So, in fact, this function is it's not a function all the way across, because no matter where you put the vertical line, it's always going to hit the graph twice. So that is definitely not a function. All right, this one is a function. If you put a vertical line, you'll only hit the graph once. So the domain in this case, it starts right here, which looks like -8. And it ends right here, which looks like 10. X can be in between those 2 numbers, anything in between. The range, the lowest point it possibly goes is -3, and the highest it possibly can be 5. So that means f of x can be anything in between. The maximum is 5, and the minimum is -3. What you're noticing about maximum and minimum, it just basically is going to be the same as your range if it's a continuous function. Increasing intervals. When does it increase? It's increasing from -8, and then it stops increasing about right here, which I'm going to say that's 0, even though I don't think it really is. I think it's actually more like -0.5. I'm going to call it 0, though. And I'm going to say it's decreasing from 0 to 5. And what I didn't realize is that it's actually increasing twice. It increases a second time from 5 to 10. So technically I should have had to give a second interval of increasing. And then the x-intercepts, it looks like -6. And the y-intercept is about 4.5. Maybe I should have just gone with 4. But it's above 4. It's clearly above 4. This one is also a function because none of the dots are on top of each other. So the domain is literally all of those points. So it can be a half. The first point is at a half. The second point is at 1. The next point looks to be exactly 2, then 3, and then, let's see, 1, 2, 3, this looks to be 4. All right, and the range is the height. This has a height of 3, a height of 2, a height of 1, a height of a half, and I'm going to assume the next one's going to be a height of a fourth because it's following that same pattern. The maximum it can be is 3, the lowest it can be is a fourth. The increasing interval, it's never increasing, it's always decreasing. It's decreasing the entire time, so that would be the same as the domain. It's decreasing from 0 to 4. And the x-intercepts, it never crosses the x-intercept, and it never crosses the y-axis. So it does not have any intercepts. It never crosses or touches either axes. All right, so your homework tonight, I'm going to split this up in both videos. I'm going to do the first 3 questions on this video and then the other 3 on the next video. So it says, determine if the statement is true or false, and then justify why. All the linear functions are increasing. That is definitely false. And the reason why it's false, and I'm just going to say the answers instead of writing them. The reason why it's false, my justification would be because straight lines can also decrease. They can also go down. So it could be a negative number times x, and therefore it would be decreasing. Arithmetic sequences are an example of linear functions. Arithmetic sequence, as I said earlier in this video, that is true. Anytime you're adding either a positive or a negative number, it doesn't matter, it's going to go in a straight line. It's because it's going at a constant rate either going up or it's going at a constant rate going down. Number 7, exponential functions have a domain that includes all real numbers. That is always true. I'm assuming that's going to be, yeah, I'm trying to think of all the ways it could be. So anytime you have a function that looks like this, or if it's going down like this, they're always going infinitely left and right. What they're not doing is they're not going infinitely up and down. No exponential function has a range of all real numbers because they all have what's called an asymptote, which you do a lot of in Algebra 2. So this is, the answer is true. And the reason being is because no matter how you draw a hyperbola, yeah, that's what that's called. It's called a hyperbola. No matter where you draw a hyperbola, it's always going to go both left and right infinitely. It's just not going to go up and down infinitely. Because of that, it always has a asymptote. All right, thanks for watching, and I'll put the other questions on the other half of the video.